I want to go back to this challenging concept of JavaScript promises. Okay. A JavaScript promise is when an object promises, it's making a promise to you, the person calling the function, that at some point in the future, the promise it gives you will be resolved to a value of some sort, or the promise will be rejected and there'll be some sort of an error, right? That things can go wrong. We use promises to write asynchronous code. Um, the reason why we write asynchronous code is not just because I want to make your life extra challenging. It's because it's really important for operations that take time. Okay. We want our web apps, we want our code to be responsive. We don't want to be sitting there like locked up for seconds, perhaps several seconds, while we wait for an operation that takes a long time. Operations that take a long time are things like querying a database, which is the code we're writing today, or fetching data from a server. Basically, whenever we're going over the internet to get something, it can take some time. And so we don't want our web app to look like it's crashed or frozen. We want to do that asynchronously. Eventually, better web design too would be like, and we have some sort of feedback on the screen to let the user know we're working on it, right? Maybe some sort of a spinny wheel or an hourglass that says we're waiting, or whatever animation we want to use to reassure them our code hasn't crashed. We're working on it. It just takes some time to do what you asked. We rarely interact with promises. We wait until those promises are resolved. Okay. And here's how we do that. So we use a couple of new keywords, and we typed them yesterday, but we really didn't get into them. It was like at the end of class. We use the async keyword before a function definition to specify that function is asynchronous. What that means is that function returns a promise, not a resolved value. We don't have to worry about writing the code to make that happen. Simply by adding the async keyword, any returned values are automatically wrapped in promises. Okay, so that's kind of cool. JavaScript makes that easy for us. It's a very core feature of doing these web apps. Um, the way that we wait for a promise to be resolved is with the await keyword. Okay, we can only use the await keyword inside of an asynchronous function. We can't just put it anywhere in our code. And what await does is it says, hey, this function I called returns a promise. Don't go to the next line of code. Instead, wait until the promise is resolved and actually has turned into like some sort of value we can do something useful with. Now you might be like, wait a minute, we just said we don't want our web app to like block or freeze, but await does exactly that. And and you're not wrong, right? So when we say await, that thread of execution will be stuck. However, Node, this JavaScript server we use for our web apps, can have many threads and other things can be going on, right? So the fact that maybe you're waiting doesn't mean that the other clients that are connected to the web server are also waiting. They can keep interacting with the web server. It also means like we can take more sophisticated approaches with this too. We can have an await running in some place, and we could be having an animation going somewhere else. So we're still giving that visual feedback to the user, like things haven't crashed. It's going to be okay. Wait a few more seconds to get your result. Okay. So we're going to see a couple of examples of async and await today. I think this is kind of vague. I believe in Canvas, I have a link to a couple of videos under extra practice that talk about promises, async, and await. I think they're done by Google developers. They're the most clear ones I could find that explain this concept. Okay, so I encourage you to check that out as well. But let's make it more concrete. Let's actually write some of this asynchronous code together and then see what it looks like. So yesterday we created a Mongo client. We used our environment variable to get the URI. That's like the web address with the username and password in it. So today we started to write the run function, which we'll call later in the script. It's asynchronous. We're going to connect to the client, and connecting to the database takes some time. So we put in a wait here because we don't want to keep going until the connection has either succeeded or failed. But once we have connected, let's go back to some of those terms that we learned yesterday in terms of Mongo, database, collections, and documents. So database and collection, or let's obtain references to a database and one of its collections. So const DB, I usually use the name DB to represent database, and then we will make this call on the client. I'm going to call the DB function, and I'm going to pass the name of the database I want to get from the client. On this instance that we provided our username, password, and address for, there are many different databases. We are going to connect to the database called sample guides. Within that database, there are many different collections. We are going to connect or get a reference to the collection. So I'll call db.collection. Notice we called the DB function on the client because the client is the connection to the whole instance. From there, we can get a reference to a database. Once we have a database, we call the collection function on the database because that gives us a reference to a collection inside that database. And we want the collection planets. Which is the collection you'll be using in your practice lab practicum. You might have noticed there's some stuff about planets on that sample output. Often with a database, we want to do like two things. We're either going to store stuff in the database or we're going to get stuff out of the database. For now, we're just going to focus on how do we get things out, how do we get data out of an existing database, or more specifically, an existing collection. Not so much about changing the values in there. We'll do that after Thanksgiving. So we do that using the function find. So find, the find function, without arguments, if we just don't pass any arguments in, it will return what's called a cursor, which is the MongoDB term. Think of a cursor as an iterator. That's exactly what it is, okay? So if we call find without arguments, we get a cursor to all documents in the collection. This is just like the iterator stuff we did earlier this semester, except instead of iterating through a linked list, we're iterating through a collection, and each element in that collection is a MongoDB document. So here's what it looks like. Let cursor equals collection.find, no arguments. That gives us a cursor, an iterator, that we can iterate through all of the documents. We're going to print out a bunch of stuff here. So let's say console.log all the planets. So each planet has its own document in the planets collection. So we're going to log all planets. We're going to want to print stuff with a cursor several times here. So we're going to write our own function to do that. So we're going to say await print all cursor. And then we're going to go write this print all function. Iterating through a collection can also be time consuming. It's inherently asynchronous. And so we don't want our code to continue to run to the next thing until we finish iterating through the collection and printing all the values. So let's jump down here and let's write this print all function. It's going to be asynchronous. So we add the asynchronous keyword, then the function keyword. It's called print all. It takes one parameter, which is the cursor. So we're making this a function. We're leveraging our decomposition skill because we're going to need this logic several places today. The methods on a cursor are similar to those on Java iterators. So this will seem familiar, which is great. So here's how we do it. We say while await cursor.hasNext. HasNext is something we're certainly familiar with. However, because asking the collection if there's any more documents, hey, do you have the next document? That can take some time. We're going across the internet, talk to the database. It's an asynchronous operation. Has next returns a promise. We need to wait for that promise to be resolved before we know if we have a document or not. So therefore, because we have to wait for the promise to be resolved, we have to put the await keyword here so that we wait for the promise to be resolved, and then we evaluate whether there's another document or not. If there is another document, we want to log it to the console. So console.log. Again, we do an await, and we do cursor.next. Next returns a reference to the document. Again, we have to go over the internet, get it from the instance. So therefore, next returns a promise. We don't want to log the promise. We want to wait for the promise to be resolved, and we're going to log that result instead. Okay. But has next and next are exactly the same methods we use with Java iterators. Okay, so at least like we have a cool connection here in terms of similarity. How many what? I'm sorry? You can have as many documents in the collection as you want. Yep, just like an iterator or like a scanner. Yeah, all the documents in the planets collection are going to be related to properties of a single planet. Yeah. Oh, great question. No. So because you're all working on your own projects, we want you to each have your own database because it certainly can happen that you like trash it by having bugs, and we don't want you to like wreck the data for other teams. Yeah. We're gonna look at that. That's a great question. Give me like a minute and we'll actually do that together. Yeah, absolutely. Mhm. Sure. But like you'll have to change it. Yeah. All right. I want to run this, but we're not quite there yet. So let's see what we're here's the try block that we started but never finished. So let's finish it by putting in the finally. So you're used to try catch. Um, we're not going to catch any errors, but we are going to add a finally. Finally means whether we finish without an error or there is an exception, regardless, run the code in the finally block. Um, we need a finally block because we need to ensure that the client will close when we finish or error regardless of what happens, even if there are errors, we don't want to leave the connection to the database open. Eventually, it will time out and go away and be cleaned up, but we want to be good citizens and actually call the close method on the client. Great question. Um, if there's an exception inside of here, we leave like it jumps to the nearest catch, right? So if there's an exception in here, code down here doesn't run because we don't have a catch here. So this ensures like we actually close the connection. We could have written a catch, caught the error, done something, printed something, and then did the close here, and that would definitely work okay. Um, all right, I think we can run this now. Let's see what happens. Yeah. Oh, like close a connection that wasn't open? That's a good question. I don't know if what happens when you close a connection you didn't make. So, yeah. Yeah, by after the await part finishes, you're saying the finally happens after like all this code finishes? Correct. Or if at any point in here we have an exception, it will run this too. Right. So if we had a catch and no finally, we need to put the client.close in two places, right? Is this going to run? Let's see. Oh, we need more code. Yeah. So here, so we defined a couple functions, but we never called them. So let's actually call them. So after our run function, let's call it. We're going to say run. I'm going to actually put a catch here. Um, this is how you often see it, like an example code with Mongo. So I can associate a catch with my function that I'm calling, and then just like log any errors to the console. So that's what's going on here. All right, let's see if it runs now. It does run. This is fantastic. Okay, I wasn't sure if that was going to work. It says all planets. We logged that. And then it's going through all the planets and printing out the entire document, which is like a JavaScript object for each planet. So here's all of our different planets. Super cool. All right, let me show you like one more thing to help you with tonight's homework. We can do a couple other things here. We could do cursor dot equals collection dot find. And inside a find, we can actually pass an object where we like restrict our query. It's like find all planets where has rings is true. I put this in the wrong place, sorry. Moving it down here so we have defined cursor. And then we can do console.log planets with rings. And we can do our await print all again. And now it's going to print, it's only going to search for those planets that have rings. We could do that filtering ourselves, but it's more efficient to do it on the database server than for us to do it. So we like stuff like this. I'm going to show you another example. I know we're rushing a little bit, but this way you'll have stuff to reference. And I will commit this to GitHub shortly. We can also do multiple things. We could say has rings is false, and then we can do comma, main atmosphere. Atmosphere is argon. And so this will be planets without rings with argon in the atmosphere. So you can do some pretty sophisticated queries. All right, I'm going to do one more. We could also do a find, and it doesn't just have to be a matching find. We can have like conditions. I can say surface temperature C, that's another property, dot mean. So that's how we can do conditions. Surface temperature C dot mean, the average surface temperature is less than 15. All of this, all these names I'm using, I got by looking at the output from when we ran this thing, right? So there's no way you would know this without looking at this output, right? Like here's main atmosphere, here's has rings, here's surface temperature, which is an object, here's the mean one of it. So surface temperature dot mean. So this is how we can do all the query stuff. That's going to help you with the homework, with the practice. At the start of class tomorrow, we'll certainly talk about the practice lab practicum. And we're going to go back over these last couple finds again because we really rushed through them. And I have one more thing I want to show you with Mongo. So we were a little rushed yesterday because I wanted to give you some of the basics you needed to do the practice. So I want to go back and kind of review that and fill in the missing pieces today. Um, so things we had done previously, we used .env to load our environment variables into process.env, one of which was Mongo URI. Actually, that's the only one we're dealing with right now. We'll have others later. We use that to make a new Mongo client. We connect it to the database. Technically, we connect it to the instance. We then the server instance. We then, using the client, connect it to the sample guides database. Then using that database, we got it referenced to a specific collection, namely the planets. I think, I don't want to mislead you. Let me double check really quick. Yeah, you're going to keep working with planets on Monday too. Okay. So at least you'll be using the same database, the same collection, the same attributes of those objects that you're using in the practice one. I'm not going to change up the database on you. Um, all right, so we learned about find, which returns an iterator. The term that's used with MongoDB is a cursor, but it functions very much like an iterator. So cursor is a reference to an iterator. We wrote this print all function, which uses the has next methods, just like scanner, just like an iterator, and next methods, again, just like a Java scanner and iterator, to see if there are more elements, and then to get each element and advance the iterator. Okay. These were all asynchronous functions, so we used await to do all of that because we don't want to log, the promise, we want to log the thing. So the new thing I want to show you is let's add an example here after the find thing, and we'll come back to these ones we rushed through yesterday, but let's add an example here which you needed for the practice lab practicum, and I'm sorry I didn't make time for that yesterday, but I did post it as a Canvas announcement. But let's do it together. If you want all the elements referenced by the cursor as an array, use the toArray function. And I know some of you, like the lab said you had to do this, and some of you just built your own array, which is fantastic, right? And that totally works. But there's a function that we can call on the cursor that does that for us, okay? So building your own array, not wrong. This is just easier. So we could say, we have to reset the cursor. It's kind of like an iterator. So we're going to say cursor equals collection.find. Now we have a new cursor that is we can use to iterate over all of the planets in the collection. And then we can say const planets equals cursor dot to array. And then we can say console.log all planets as an array and console.log planets. You could. Yeah, you could do it all in one line if you want. Absolutely. When we run this, let's look at what we see. I'm going to run it again because I had a lot of old output there and I don't know where it started. All right. All planets, blah, blah, blah. I want to see all planets. All planets as an array. Huh. All right. Take 30 seconds, talk with your neighbor. What is going on here? Why is the highlighted text displayed to the console? What does it mean? And that's not what I want. So how do we fix it? So take 30 seconds to talk about that. What do we think? What does this mean? Yeah, Jay. We do need an await because what is this printing to the screen? Yeah, it's printing the promise, right? So remember, almost all of these functions that interoperate with Mongo are asynchronous. These functions don't return a value. They don't return a reference to an array. They return a promise, right? So this is something we've talked about over the last couple of days. This is kind of like our big new challenging concept this week for JavaScript. A promise means like, I promise to give you an answer later. I don't have it right now. Okay. Technically, it's like, I promise to give you an answer later or let you know I can't, but I will get back to you. Okay. Um, so you might run into this in your code. You might run into this on the summative lab practicum and you expect like planets, and instead you get this thing when you print it that says promise, right? Um, or you run your code and you get an exception because you try to like index into a promise, and like, what's that index to in a promise? That doesn't mean anything, right? So, or you're stepping through your code in the debugger and you're like, it's a promise. That's weird. What does that mean? Um, so when you see this, it just means like we're trying to do something, but we never waited for the promise to be resolved. And so, as Jay said, exactly what we need to do is add that await in to say, wait for this to happen. So I'm going to add the await right here, await cursor.to array. By adding that await, now when I run this, I have nothing. That's strange. Hmm. Yeah. Oh, if we didn't have the await and we just slept instead? Sure. Yeah, let's not do it that way. But yes, that would absolutely. Did someone accidentally delete the data in our database? Playing around with it? Our database looks empty now. I mean, I can put it back, but I don't want to take class time to do that. But we have no planets. Someone deleted all the planets in the solar system. I'd blame Mr. Callahan, but I can see his laptop is here, so it wasn't him. No, I'm just kidding. All right. Well, let's add some comments and I'll fix the database later. Um, let's not write to the database. Let's only read from the database until we learn how. Um, yeah. All right. So where do we leave off? So this is how we do the to array thing. The next thing I wanted to share here was that we can find with a query object, we'll return a cursor to all documents that match the query. Could we get all the documents and write our own for loop to look at each document and do our own filter? Absolutely. But that's not nearly as efficient as having the server, the database server, do the query and the filtering for us and just give us back the data we want. Imagine we had a database with millions of documents in it, and we're looking for just like 5 of them. We don't want to transfer a million documents over the network for us to filter through to find 5. We want the server to find the 5 and send us those 5 documents, right? Um, so yes, so this is a good thing to do. A query object is right here. So we're using the object literal syntax. Um, we can put whatever property names we want, like we have all the different properties for the planets, and then we can put the value we want to match. Okay. Here's an example of using a query object that just checks for one property. As rings is set to true, we just get the planets with the rings. Okay. But let's add a comment for here. There can be multiple properties in the query object, and all must match. Like by default, it's an and, okay? So this says, in our collection, find all documents where has rings is set to false and main atmosphere is set to argon, okay? So finds planets without rings and argon is in the atmosphere. If you want ors and stuff too, we can do that. The syntax gets a little bit more complicated. But by default, it's an and thing. I want to find things that have this and this and this. Okay. So now our query object has two properties defined with the values that's our query. Finally, it's not like we can query more sophisticated queries, not just like, does it have, like, is the property this value? We can use operators. So operators can be specified. So this gets back to the earlier question. Here's our list of most common operators. We could use LT for less than, GT for greater than, which is what you needed in the practice practicum, LTE, less than or equal to, GTE, greater than or equal to, any, not equal to, $in, like contains, $n in, not in. Okay. So less than, greater than, less than or equal to, greater than or equal to, not equal to, in, and not in. So the thing we rushed through right at the end of class yesterday, this says in our collection, find all the documents where the surface temperature C dot mean. So surface temperature C was a property that itself was an object with additional other properties, min, max, mean. We are focused on mean where it is less than 15. Notice that we have to put this in curly brackets. Like we build a little object here and we assign this property $LT to a value of 15. So this is how we can, like, basically we're building little JavaScript objects that get passed along to MongoDB to do these types of queries. Okay. So here's the less than 15 part. You can do much more sophisticated queries in MongoDB. We're not going to worry about that this semester. Okay. Some of our projects next semester warrant that type of sophistication. Most do not. We don't have that many documents. This really covers all the basics for what you need. So, yeah, questions? Yeah, great question. So for efficiency reasons, find is not asynchronous because it builds the query and returns a cursor, but that can be done like immediately because it doesn't require accessing the database yet. It's not until we start iterating through the cursor with like the has next and the next that we actually have to go and get that document from the database. So that's why we have to say await cursor.has next, await cursor.next. Exactly. Yep. Great question. Yes. So find doesn't have to go do something time consuming with a database. It's just returning a cursor. So that doesn't require like accessing any documents yet. So find is not asynchronous. So we don't need the await. It doesn't return a promise. But we do need the await whenever we use the cursor, like cursor.hasNext, cursor.next, cursor.toArray. All of those actually have to get documents from database. So we have to have await. We're building a JavaScript object. This is our syntax for a JavaScript object literal. with a property $LT that has a value of 15. Well, so the planet has a property called surface temperature C. That property is really an object, and that object has a series of properties, one of which is mean. So this is how we can't say surface temperature C dot mean here, like like we put it in quotes because we're we're building two JavaScript objects here that we're going to pass to the find command, right? Here's the first object, like it's the whole thing, and it has one property which is surface temperature C dot mean, but we need the quotes because otherwise it would try to treat this like right like a variable and dot, right? So this is the first property name. The value of this property for this query object we're passing to find is another object which has the property $less than set to 15. Um, no. Yeah, think of it more as so we're not like directly referencing the object here. We're specifying a query for the database to run. So we're saying here is the property, which might be buried multiple dots deep. Here is the property we want to query, and here's the operation we're going to look on it. Yeah, it's kind of weird, right? And it's a little bit odd too because we have to write this code in JavaScript, but we're really trying to do like a database operation. Yes. So